Next problem up. First thing we'll do as always, read the question sentence first. So here we are. Question sentence reads, if we have this many students in total, how many boys are there? Okay, so right there, everybody, we have to understand that if we don't know what the question's asking us to figure out, then we're going to be wrong. So watch this here. We're given 130 students in total, but what we're actually looking for, everybody, is the count for the number of boys. Can we agree on that before we continue? Because again, this is where your confidence comes from, knowing what you're looking for before we talk about how we're going to look for it. So right here again, how many boys? We are given, right over here, 130 students in total. So allow me to write a ratio out. Now, it doesn't matter which way I write this. I just want to compare total and boys. We can do boys to total or total to boys. Either way is fine. Just be consistent and compare the same things in the same way, and you'll be fine. So here we go. Allow me over here to just write that out, and I'll say boys in the numerator, and then I'll say total in that denominator. So now I have my comparison. Now I have my logic. I'm comparing boys to total, boys first, total second. And now I'll just write the skeleton here for the proportions. Boom, right there. All right, now let's get to work. Now I know I'm looking for boys, so I'll say B. And I know I'm given 130 students in total, so I'll put 130 in the denominator. Now here's where we want to be careful. We're given that ratio, saying in a classroom, boys and girls are in a ratio of 6 to 7. And so how do we take care of that? Well, one of those numbers is useful. The other number is also useful, but not for the reason you think. So first, let's go ahead and just categorize. Everybody, the 6 represents which of the two groups? Because it was written first in the ratio, the first word that we see, it was boys. Boys first, 6 was first. So the ratio is 6 boys. And then girls is second, 7 is second. 7 represents the girls. Now, hold your horses, because I know the temptation is super obvious and clear. I want to throw 6 up there, 7 on the bottom, and then see what happens. But this is how we get the question wrong. This is exactly how we get the question wrong, because guess what, everybody? First, boys is up top. Does 6 represent boys? First, answer that. Does the 6 represent boys? Correct, it does. That is right here. That is correct. That's good. But here's the second question. Again, are we comparing the same things in the same way? Does the 7 represent total? It does not. The 7 represents girls. So that's how I know, before I even try to calculate this, I know that this is wrong. There's a waste of time waiting to happen if I decide to calculate. So that's why I'm going to take the 7 out, and I'm going to ask myself, I need to get total here in the denominator. I'm not given the total, but I can get the total by adding the parts. 6 parts boys, 7 parts girls. Add those together, and we get their total, which is 13. 13 total students there. And so we'll go ahead and write the 13 where it rightfully belongs. And guess what? Once you have the setup done, you're good. We can perform any agency of techniques that we want to here. We can do cross multiplication and division, but I'm going to look at that and say, nah, I'm good. And instead, I'm going to opt to look at the comparison strategy, which is if I look at top to bottom or right to left, is there a comparison that I can take advantage of? And there is. Because if I take a look right to left here, 13 to 130, that's a pretty, that's one of the more obvious ones. I'm not going to say everything is obvious, but this is on the more fundamental side, because 13 times 10 is 130. And if we compare the same things in the same way, 6 times 10 gets us the answer, which is answer choice C. 6 times 10 gives us 60, and there we go. All right, so next question, but no matter what, everybody, we're going to handle it with the same grace. we're going to handle it by understanding the question sentence first. So what is it that we want? The question sentence says, if there are 72 animals in total, how many dogs are there? Again, we have this many animals in total. How many dogs are there? So everyone, let's be careful here. First, in one word, what is it that we're looking for? At the end of the day, at the end of the problem, what do we want to say we have a number for? Dogs. Perfect. That's all we have to say. We are looking for the number of dogs. Again, how many dogs? Now, what we're given is we're given the total right there. That's going to be imperative. Like, this is 100%, no excuse is important, because it's going to allow us to get the correct answer in as minimal steps as possible and as little time as possible. So first, what I'm going to do is I'm going to write the comparison. I'm going to say that we are comparing the total number of animals to the number of dogs. Because remember, when we're solving proportion word problems, it's always easiest to solve the problem by setting up your proportion based on the question sentence. Total dogs, perfect. Up next, I'll just go ahead and fill in my proportion or my skeleton for it. And now what I'll do is I'll trace the rest of the information, because I saw that there was a ratio that I haven't addressed yet, and I'll do that now. In a pet store, dogs and cats are in a 6-to-3 ratio. Everybody, quick question. Are the 6 and the 3 all I need to solve this? Like, can I plug in 6 and 3 and 72 and total or dogs and be done? No, not at all. Here's why. First, let me just backtrack right over here. 72 animals in total. So I'll write 72 animals for the total. Again, just lining it up. Then D for dogs, because we're looking for dogs. Now we're going to compare the same things in the same way. Everybody, on the bottom here, I have to represent the bottom. Don't give me the number, but what the bottom represents has to be what? What the bottom represents has to be dogs. Yeah, has to be dogs. So when I take a look at this 6-to-3 ratio, the 6 represents dogs and the 3, it represents cats. So I'm going to write 6 for dogs, and that is correct. Yeah. Now the mistake is going to be thinking that all you have to do is plug in 3 right up here and you're done. The reason that is a mistake is because, everybody, when we pull this over here, is this consistent? Are we representing the same things in the same way if I'm putting cats up here, but I have total right here? Yeah, so that's the problem. That's the issue. That's why having 3 up here won't give you the correct final answer. That's exactly why. What I need up there is exactly what I said I needed up there, which is total. I need to represent total. And we get a total from a ratio by adding the parts. Because notice, dogs is not total, cats is not total, but if we add dogs and cats together, that will indeed give us a total. And now we have the proper value for the numerator, and now I can solve this in a much faster way. So this is how we'll do it. Now that we know we have the right setup, duplicate it right over here. Let's solve it. We can go ahead and solve this actually without cross multiplying. We noticed that if I wanted to go from right to left, we can. Everyone, what do I multiply 9 by to get to 72? Yeah, conveniently, that's 8. So remember, comparing the same things in the same way, we can multiply by 8 from right to left. 6 times 8, that'll be 48. And that is the number of dogs that we have. 48 dogs, boom, answer's correct, which is answer choice B.